Welcome, class. Today we'll be learning about probability. Now, probability is the word that we use when we're measuring the chance that an event is going to happen. So, probability means how likely is it to happen. And if it's unlikely, we give it a 0. And if it's likely, we give it a 1. So the probability of something happening is between 0 and 1. 0 means not likely, not going to happen. 1 means likely, it is going to happen. And if it's neither unlikely or likely, if it's somewhere in between, we could say it's 1/2. So let's just think about a couple examples together here. What is the probability of the sun shining on a July day? Think, is it unlikely, neither, or likely? You probably guessed likely. Let's think about here. Let's take a look at the probability of it snowing in July. What's the likelihood in Minnesota that it's going to snow in July? That would be, in Minnesota sometimes it's questionable, but that would probably be unlikely. Let's take a look at a couple more of these here. Let's see, how about Wisconsin snowstorm in January? It's likely. Christmas occurring in April? That would be unlikely, impossible. How about rolling a 7 on a standard die? How many sides does a standard die have? Dice have 6 sides, so that would be unlikely. Or how about rolling an even number on a standard die? Sure, that's likely. Now we're going to talk about how you measure or calculate theoretical probabilities. So this is when we're guessing, or we're making an educated guess, we're measuring how likely is something to happen. So the theoretical probability is what you expect to happen. This is what you expect. It's not a guarantee that it's going to happen, but this is what you expect. And to measure the probability of something happen, we measure or we count the number, that's what this symbol means, the number of desired events. So if you want to roll an even dice, that would be how many times could you roll an even dice? And you divide that, you put it over the number of possible outcomes. So the number of possible outcomes on a dice, for example, well, here, let's just take a look at this example right here. Example number 1. So on top here, we're going to talk about the number of desired events. And if what we're asking is rolling a 3 on a standard 6-sided die, what's the P, that's the probability of rolling a 3? Okay, well, how many 3s are there on a 6-sided die? There's 1. So rolling a 3, the probability is 1. There's 1 possibility. And a 6-sided die has 6 sides, obviously 1, 2, 3, 4, 5, and 6 different sides. So we'd say that if we're going to write this as a probability, it would be 1 over 6. Let's take a look at another example. If you rolled the die 24 times, how many times would you expect to roll the 3? Well, in that example, let's see here, sorry. In that example, that would be 1/6, like we found here, times, well, if we rolled it 24 times, that would be times 24. So, what is 1/6 times 24? Well, that's like saying 6 times 24 wholes. That's like 24 divided by 6, and that equals 4. So the probability I would expect if I rolled a dice 24 times that I would roll a 3 4 times out of 24. Let's look at another example. One more example here. So what's the likelihood of rolling an odd number? That's what we have up here. What's the probability of rolling an odd number? Well, let's see here. How many odd numbers are on a dice? There's a 1 and a 3 and a 5, okay? And what are the total number of possible outcomes? Well, there's 1, 2, 3, 4, and 5. Those are all possible outcomes. Okay, so that means that there are three odd numbers, 3 desired events out of 6 possible sides I could roll. And if I reduce this fraction, let's see, I can divide both of these by 3. Then I would get 3 divided by 3 is 1, and 6 divided by 3 is 2. So this is just an example of how we measure the experimental probability. We can even do it with a coin. What's the probability of flipping a head, getting a heads? Well, there's 1 heads on a coin, and there are 2 possible sides. So the probability is 1/2. How about the probability of flipping tails? Well, there's 1 side that has tails, and there are 2 possible sides. That's 1/2. Rolling a 6-sided die, let's see here. What's the probability of rolling a 4? Well, there's 1 4, and there are 6 sides on a dice. How about the probability of rolling a 1 or a 2 or a 3? Well, let's see here. That's 3 sides out of 6, or 1/2. How about the probability of rolling a 6? Well, let's see. There's 1 side out of 6. And last, let's take a look at calculating an experimental probability. The experimental probability is what actually has occurred, instead of what you just expected to happen. So you calculate the experimental probability by running an experiment, doing an experiment, and then measuring the number of times that you got the desired outcome, the number of times that it occurred. So I'm flipping a coin, and my question is, how many times do I get heads? You flip a coin a bunch of times, and just write down how many times you got heads. And the bottom is going to be the number of actual trials, the number of times you actually flipped it, number of trials, or the number of times you actually ran the experiment. So for the first example, if you roll a dice 10 times and you got the following results, you got a 2, then you got a 5, then you got a 4, and a 2, and a 1. If the question is, what's the chances of finding a 2? Well, on the top here, you're going to write how many 2s did you get. I count 1, 2, 3. So the number of times 2 was rolled is 3. The number of total trials is, let's see, how many times did I get? Let's see, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the probability is 3/10. So that's how we find the experimental probability. In today's lesson, you are going to do an experiment yourself. You're going to investigate the probability of rolling a dice. So I'm going to give you a link here. It's just going to send you right here to this dice roller where you can roll this dice as many times as you want. And you're going to run this experiment yourself. Just follow the instructions. Step 1, complete the first 2 columns before rolling your dice. So the first 2 columns are right here. Here's the first column, here's the second column. So for example, what is the theoretical probability of rolling a 1? Well, I'm going to write a fraction line. Let's see here. How many sides does a dice have? It has 6 sides. How many 1s are there? There's 1, 1. So I'm going to write a 1 down. And what's the probability of rolling an even number? Well, how many even numbers are there? There are 3. So I'm going to write 3 down. How many total dice are there? 6. So how many times do you actually expect to roll a 1 or to roll an even number? Have some fun with this. Let your teacher know if you have any questions, and good luck.